AI philosophy, enabling humans to establish destiny for themselves and establish a mind for AI. Different thinking processes between humans and AI in problem solving. Humans demonstrate great flexibility and creativity through self-awareness and subjective experience, intuition and creativity, flexibility and adaptability, ethics and values, as well as emotional communication, whereas AI excels in rapid computing capabilities and efficient data processing. Click the plus icon to follow this account for more exciting content. There are significant differences in thinking processes between the human brain and artificial intelligence (AI), which are mainly reflected in the following aspects: problem understanding and representation. The human brain typically understands problems from intuitive and experiential perspectives and may represent problems using graphics, images, or intuition. It is adept at lateral thinking, trial and error, and heuristic search strategies, which involve discovering hidden components, tacit knowledge, assembling structures, or adopting unexpected perspectives, and finding optimal solutions through continuous trial and adjustment. AI relies on the format and preprocessing of input data, and usually requires problems to be converted into forms suitable for algorithmic processing, such as numerical matrices or specific data structures. Learning methods. The human brain comprehends the world through perception, experience, learning, and memory. Its learning process is flexible and nonlinear, involving sensation, emotion, intuition, and other aspects. In contrast, AI systems learn based on large amounts of data and algorithms, lacking human intuition and creative thinking. AI learning is generally pattern and rule-based, requiring massive data input and repeated training to improve performance. AI is highly dependent on the quality and quantity of training data and cannot learn quickly or extract key features from a small number of samples like humans. Reflection, iteration, and revision. The human brain may constantly iterate and revise its thinking during problem solving, a process that can be nonlinear and may involve reinterpreting the problem. AI iteration is usually part of its algorithm, such as optimizing model weights through multiple iterations in machine learning. Such iterations are predefined and often linear. Creativity and innovation. Humans possess unique creativity. The human brain can innovate, invent, and solve complex problems, transcending traditional algorithms and patterns to generate novel ideas, works of art, and technological inventions. This ability stems from rich imagination, interdisciplinary knowledge integration, and socio-cultural influences. AI can produce seemingly creative outputs by analyzing large volumes of existing data, but this is essentially based on predefined algorithms and models. Its creative thinking is a recombination of existing data without genuine originality, and it cannot think outside the box as humans do. Adaptability. Humans easily adapt to new, open environments and unseen problems, using existing knowledge for association, analogical reasoning, and transfer learning. The human brain can quickly adapt to new environments and tasks and acquire new knowledge from experience. While AI systems may perform powerfully on specific tasks, they are often inflexible and underperform in new situations, easily hitting dead ends. Even state-of-the-art AI models struggle to transfer learned knowledge to completely different contexts, i.e., limited generalization ability, requiring extensive training data and retraining for adaptation, with limited transfer capacity and typically only handling problems similar to training data. Error handling. The human brain can identify and interpret errors, sometimes correcting them even without fully understanding their causes, and can use errors as learning opportunities, which may involve re-evaluating the entire problem framework. AI may fail when encountering errors or abnormal data, requiring explicit error handling mechanisms or additional training data to improve performance. AI often needs external intervention when errors occur, such as adjusting algorithm parameters or providing more training data, and generally lacks self-correction ability. Handling problem complexity. When facing highly complex problems, the human brain can address them through abstraction, simplification, or iterative approximation to find solutions. AI may be constrained by algorithmic complexity and computational resources when handling highly complex problems and may perform poorly on unstructured or non-conventional problems. Understanding and consciousness. The human brain can understand complex concepts such as language, context, and emotion, and possesses self-awareness and cognitive capabilities. Most AI systems operate based on predefined rules, algorithms, and models. Such pattern matching and statistical learning lack genuine understanding and consciousness. They may excel at specific tasks but do not have general comprehension ability. Intuition and perception. The human brain has intuition and perception, enabling judgment and holistic thinking from incomplete, ambiguous, or even contradictory information. AI systems lack human-specific thinking abilities such as intuition, insight, and creativity, requiring clear and precise data and rules, with weak capabilities in handling vague or incomplete information. AI typically uses probabilistic models or fuzzy logic for such tasks, emotion, and consciousness. Humans have self-awareness and can reflect on their thinking processes and behavioral outcomes. They also possess rich subjective experiences, including perception, emotion, memory, and imagination, which cannot be simulated by current AI. For example, a passion for physics may motivate someone to devote more time and effort to solving difficult problems. Although AI can process emotional data and simulate emotional expression in conversation, this is merely superficial. AI emotional responses are mostly based on predefined algorithms and rules. They do not truly understand emotion because they lack subjective experience and reflection. Information processing strategies. The human brain processes information through biological neural networks, showing great flexibility, adaptability, abstraction, nonlinearity, and associative leaps. It is not skilled in high-precision numerical calculations and has relatively weak parallel processing ability, struggling with multitasking parallel processing. AI, by contrast, relies on artificial neural networks, computer programs, and algorithms excelling in linear operations. While its computational precision, speed, and storage capacity far exceed the human brain, it lacks the biological characteristics of the human brain. Moral and ethical judgment. Value judgment and ethics are essential components of human thinking. Humans make decisions based on their values and ethical principles, considering various interests and consequences. Such judgments often involve complex moral reasoning and trade-offs. AI faces significant challenges in value judgment and ethics. Lacking emotion and ethical awareness, AI systems struggle to make complex moral decisions and are prone to bias and discrimination. AI decisions are mostly based on factual data and algorithmic optimization, rather than ethical considerations. It can be seen that humans demonstrate great flexibility and creativity through self-awareness and subjective experience, intuition and creativity, flexibility and adaptability, ethics and values, as well as emotional communication, whereas AI excels in rapid computing capabilities and efficient data processing. Although artificial intelligence performs well in certain fields, such as speech recognition and image processing, the human brain retains unique advantages in creative thinking, emotional understanding, and consciousness. These differences keep the human brain superior in complexity and depth, driving technological innovation and development. I am Wu Huaiyu, a PhD from the Chinese Academy of Sciences and a postdoctoral fellow from Peking University and the founder of AI philosophy. For more detailed information, please refer to the complete version of this book. In addition to this short video, you can also click on my avatar to view more long videos.